Hey everybody, today we're going to talk about reading a box and whisker plot. Alright, a box and whisker plot is just a graph that's going to summarize a set of data on a number line. It has a box and two whiskers are the three main parts that it consists of. This is the first day that we're going to talk about box and whisker plots. Tomorrow we'll actually talk about making them. Okay, so a typical box and whisker plot looks like this. You start with a number line, and then you have your box, and then two whiskers coming off the sides of it. Okay, so each part on this box and whisker plot represents something. Our median is something we're very familiar with. Remember, our median is the middle of our data. Okay, and the median is actually going to be our middle dot on the graph, which is going to be this dot right here. So this is our median. And when we're referring to a box and whisker plot, sometimes you'll see this called Q2 or quartile 2. Okay, you might hear me call it Q2 sometimes. All right, another thing that most of us are familiar with is a minimum and a maximum value. Our minimum value is, you probably guessed it, is going to be the last dot. So this is our minimum. And our maximum then is going to be our last dot. Okay. All right, and then the two new terms that you guys have are going to be called quartile 1 and quartile 3. Well, quartile 1 is actually this dot right here, so we're going to call that Q3, or sorry, Q1. And then this one right here is going to be Q3. All right, now we all know how to find the actual median of a set of data, correct? It's the middle of the data. You lined up from least to greatest and find the middle. Now to find Q1 and Q3, Q1 would just be the median of the lower half of the data. So you're going to split the data into two sections, and you're going to find the median of the lower half. That would be Q1, and then you're going to find the median of the upper half, and that would be Q3. But we'll talk more about how to actually find those tomorrow. Okay, some more things that you can read on the box and whisker plot. Is that you have your data and it's going to be split into 4 different chunks, okay? Meaning each part is going to be 25% of the data. So from the minimum to Q1, that's going to be 25% of the data. Okay? From Q1 to Q3, that's going to be 50% of the data. So the box consists of the middle 50% of the data. And then the top whisker is going to be 25% of the data. And the reason we know the middle box is 50% is because from here to here would be 25%, and here to here would be 25%. Now when I'm talking about part of the data, I mean, for instance, that from minimum to Q1, 25% of your data values is going to fall between the minimum and quartile 1. Okay, 50% of your data values are going to fall between Q1 and Q3, and 25% of your data values are going to fall between Q3 and the maximum. We just use this to be able to read our graph and be able to figure out where some things actually fall on the graph. Okay, so let's look at an actual example here of a box and whisker plot and read some things off of it. Okay, our median is going to be our middle dot. So our median is right about 400 seconds. Okay, our maximum is going to be right about 600 seconds. Our minimum is going to be right about 100 seconds. our Q1, the median of the lower half of the data, is going to be right about 300 seconds. And then finally our Q3, our median of the upper half of the data, is going to be right about 500 seconds. Alright, and notice how my number line has the values on it. So I always label my number line, and then I always label it with a title, kind of like our frequency tables and histograms. Okay, some other things that we can read off of this. You might be given a question something like, how much of the data has a song length greater than 300 seconds? Well, here's your 300 seconds. Okay, song lengths greater than 300 seconds would be anything this direction. And we want to know the percentage of the data that has a song length greater than 300 seconds. So if we remember, the box is 50% of the data, and this whisker is another 25%, so a total of 75% is greater than 300 seconds. Okay, maybe we'll be asked a question, how much of the data is less than 400 seconds? Well, 400 seconds would be right here, and less than would be anything to the left, so we have 25% here, and then another 25% here on this end, so a total of 50% is less than 400 seconds. Okay, and those are some things that we can actually read off of the box and whisker plot. Alright, and then finally you might be given a box and whisker plot that actually compares two things, such as the average rainfall in inches in Bellevue and Chicago. So if you remember what range is that we just talked about, range is the highest value minus the lowest value. So when we look at the range of these two box and whisker plots, we're going to take our maximum for Bellevue, which is about 8.5, and we're going to subtract our lowest value, which is 3. So here's our maximum, here's our minimum. And when we do that, we should get 5.5. Okay, if we want to look at Chicago, do the same thing, except now my maximum is 9 minus my minimum, which is about 2. So my range is going to be 7 for Chicago. Okay, so the greater range is actually going to be Chicago in this case, right? Now, without even, the nice thing about these box and whisker plots is you can actually figure out the greater range without even doing all those calculations. Okay, if you look, the greater range is actually going to be the longer box and whisker plot. So if we look, Chicago actually has a longer box and whisker plot. So therefore, it's going to have the greater range. Okay, the other thing we can talk about is interquartile range. Okay, when I talk about interquartile range, it's very similar to the actual range, except interquartile range is just talking about the actual box. Okay, so it's talking about the box for Bellevue and Chicago. All right, so if I want to look at the interquartile range for, let's go Bellevue. Okay, I'm going to take my Q3, which is 7, and I'm going to subtract my Q1, which is 4. So my interquartile range for Bellevue is 3. If if I want to look at Chicago, the same thing. Okay, Chicago has a Q3 of about 5 and a Q1 of about 3. So 5 minus 3 gives you 2. So the greater interquartile range is going to be for Bellevue. And if you notice, once again, the bigger box is in Bellevue, and that also had the greater interquartile range. In other words, IQR would be an abbreviation for that. Okay, so once again, easy way to do it without actually calculating it is just find the bigger box. The bigger box will tell you the greater interquartile range. All right, and that is pretty much how to read a box and whisker plot. Okay, for tomorrow, please look at this box and whisker plot and tell me what is the quartile 1 and what is the maximum.